to see here because this isn't written the way we normally write a proportion. Okay, so I'm going to rewrite these numbers so you can see it two different ways. This is a proportion because it is two equal ratios, or the way I like to think of it, two equal fractions. And what they're trying to say is the outside numbers of the proportion. So I'm going to circle them in blue over here, and then in blue over here as well. These two numbers are called the means, or the extremes, sorry. These two numbers are the extremes. They're the outside numbers. And if you think about it, I go numerator, denominator, numerator, denominator. Obviously this was my first and this was my fourth. So these are the extremes. They're the outside parts of my proportion. And then we have the means. The means are the middle parts. And if I was going through 1, 2, 3, 4, that would be my second and my third number. Okay, you've probably already seen this before. Just remember, extremes are on the outside, means are in the middle. Okay. What we use this terminology for, means and extremes, is that whenever we have a proportion, the product of the extremes is equal to the product of the means. So if I had A over B equals C over D, what I can do is I can cross multiply and then set the things equal to each other. A times D equals B times C. And this is going to allow us to do a much easier way of comparing two different ratios, because if we know they're equal, they must form a proportion, which means the cross products must be equal. So the way to test to see if two ratios are equal or if they are proportional, we can just look to see if their cross products are equal. If they're equal, it must be a proportion. If they're not equal, it must not be a proportion. And one thing real quick before we look at that example, a lot of times you guys have heard cross multiply and then divide. Do not ever think of that again, okay? I don't want to use that trick because it does not work all the time. It is a bad habit to get into. So we do not cross multiply and divide. When we have proportions, we cross multiply, and I want to make sure we all write this down because we need to get in this habit. Cross multiply and set equal. We're going to cross multiply both directions in our proportion and set those two things equal to each other. But now we're just going to look and see, are these two things proportional? If they're proportional, it would mean they were equal. And if they were equal, then I could cross multiply and get the same thing either way. Which means I could do 2 times 14. And when I do 2 times 14, I get 28. And then I should be able to multiply it the other way, 3.5 times 8. And there I get 28 as well. The product of the extremes equaled the product of the means because I cross multiplied and set equal. And that means this is a proportion. So in fact, this was a proportion. And this is much nicer than doing it the way that we did in example 1. I much prefer this method. It's a lot easier. So here I want to see if 0.3 over 1.5, does it equal 0.5 over 2? Well, if it did, then I would know the product of the extremes, 0.3 times 2, which is 0.6, would equal the product of the extremes. And when I do 0.5 times 1.5, I do not get 0.6. I get 0.75. And since these are not equal, and the way we show not equal is we put a slash to the equal sign. These are not equal, so this is not a proportion. We would say no, these ratios do not form a proportion because when I took the product of the extremes, it was not equal to the product of the means.